This video is the part 1 of AZ-204 exam series and contains some important topics and questions related to those topics. You can find the complete PDF of this video and our practice exam questions through the link down in the description. We have more than 30 plus certifications and are here to help you achieve your certification goals. We will try to answer all of your doubts related to AZ-204 exam, such as the exam does have lab type questions. The exam also comes with case study type questions. The exam duration is around 120 minutes in which you have to answer 40 to 60 questions. The minimum passing score is 700 out of 1000. There is no negative marking in the exam. This certification will be valid for a year after you earn it. About the exam renewal process, you have to recertify and it is free. This is a tutorial video for the AZ-204 exam and also contains practice questions. We will be covering these topics in this video. However, these are not all the topics that will come in the exam. As such, we will be publishing more videos in the future. So please make sure to subscribe our channel and press the bell icon. To our first topic, Azure functions. Now, what is Azure function? It is a serverless solution that allows you to write less code, maintain less infrastructure, and save on costs. Instead of worrying about deploying and maintaining servers, the cloud infrastructure provides all the up to date resources needed to keep your applications running. You focus on the code that matters most to you in the most productive language for you, and Azure Functions handles the rest. Through the diagram, you can see how Azure Function works. It basically combines your code and events and data. More about Azure Function. Azure Functions is an event-driven compute on-demand experience that extends the existing Azure App Services application platform with capabilities to implement code triggered by events occurring in Azure, in third-party service, and in on-premises systems. Functions lets you build solutions by connecting to data sources or messaging solutions, which makes it easier to process and react to events. Function runs on Azure data centers, which are complex with many integrated components. In a hosted cloud environment, it is expected that VMs can occasionally restart or move, and systems upgrades will occur. Your function apps also likely depend on external APIs, Azure services, and other databases, which are also prone to periodic unreliability. About custom handlers, every functions app is executed by a language specific handler. While Azure Function features many language handlers by default, there are cases where you may want to use other languages or runtimes. Custom handlers are lightweight web servers that receive events from the functions host. Any language that supports HTTP primitives can implement a custom handler. Custom handlers are best suited for situations where you want to implement a function app in a language that is not currently offered out of the box, such as Go or Rust. Implement a function app in a runtime that is not currently featured by default, such as Dino. With custom handlers, you can use triggers and input and output bindings via extension bundles. About Azure Durable Functions, it is a feature of Azure Functions that lets you write stateful functions in a serverless complete environment. The extension lets you define stateful workflows by writing orchestrator functions and stateful entities by writing entity functions using the Azure Functions Programming Model. Behind the scenes, the extension manages state, checkpoints, and restarts for you, allowing you to focus on your business logic. The primary use case for durable functions is simplifying complex, stateful coordination requirements in serverless applications. To the questions related to the same topic, Question 1. You develop Azure durable functions to manage vehicle loans. The loan process includes multiple actions that must be run in a specified order. One of the actions include a customer credit check process, which may require multiple days to process. You need to implement Azure durable functions for the loan process. Which Azure durable function type should you use? Here in this question, we want a function that will run some specific actions in a specified order. As per this requirement, the most appropriate answer is orchestrator. As such, the correct option is A. An orchestrator function is the appropriate type of Azure durable function to use in this scenario because it allows you to define the overall flow of the loan process and call other functions or activities as needed. The credit check process can be implemented as a separate activity function which can be called by the orchestrator function and run in parallel with other actions in the loan process. Entity functions are designed for use cases where you need to perform operations on a shared piece of state in a reliable and atomic way, such as a distributed queue or counter. In this scenario, it does not appear that there is a need to use entity functions. There is no such thing as a client function in Azure durable functions. Activity functions are called by orchestrator functions to perform specific tasks, but the orchestrator function is the only one that defines the overall flow of the loan process. So it is the correct answer in this case. Question 2. You are developing an Azure durable function to manage an online ordering process. The process must call an external API to gather product discount information. You need to implement the Azure durable function. Which Azure durable function types should you use? Each correct answer presents part of the solution. Note, each correct selection is worth 1 point. Here in this question, we are developing a function that will manage an online ordering process that must call an external API to gather product discount information. With these requirements, the most suitable functions to use are orchestrator and entity. As such, the correct options are A and B. The durable function extension exposes a set of built-in HTTP APIs that can be used to perform management tasks on orchestrations, entities, and task hubs. These HTTP APIs are extensively webhooks that are authorized by the Azure Functions host but handled directly by the Durable Functions extension. Question 3. You are developing an Azure Function app that processes images that are uploaded to an Azure Blob container. Images must be processed as quickly as possible after they are uploaded, and the solution must minimize latency. You create code to process images when the function app is triggered. You need to configure the function app. What should you do? Here, we want to create a function app that will process images quickly and with minimum latency. Considering these requirements, the most appropriate option is to use an app service plan. Configure the function app to use an Azure Blob Storage tier. To use an Azure Blob Storage trigger. Thus, the correct option is D. Use an app service plan. Configure the function app to use an Azure Blob Storage trigger. Consumption plan can cause a 10-minute delay in processing new blobs if a function app has gone idle. To avoid this latency, you can switch to an app service plan with always on enabled. Question 4. You develop an HTTP triggered Azure function app to process Azure storage blob data. The app is triggered using an output binding on the blob. The app continues to time out after 4 minutes. The app must process the blob data. You need to ensure the app does not time out and processes the blob data. Solution. Configure the app to use an app service hosting plan and enable the always on setting. Does the solution meet the goal? Here we have an HTTP triggered function app that must process the blob data. However, it times out after 4 minutes. And we need to ensure that it stops timing out and processes the blob data. Considering these requirements and the given solution, the appropriate option here is no. As such, the correct option is B. Instead, pass the HTTP trigger payload into an Azure Service Bus queue to be processed by a queue trigger function and return an immediate HTTP success response. Question 5. You develop an HTTP triggered Azure function app to process Azure storage blob data. The app is triggered by using an output binding on the blob. The app continues to time out after 4 minutes. The app must process the blob data. You need to ensure the app does not time out and processes the blob data. Solution. Pass the HTTP trigger payload into an Azure Service Bus queue to be processed by a queue trigger function and return an immediate HTTP success response. Does the solution meet the goal? Here in this question, considering the requirements that are same as before, the solution is correct. As such, the correct option is yes. Thus, the correct option is A. Large, long-running functions can cause unexpected timeout issues. General best practices include, whenever possible, refactor large functions into smaller function sets that work together and return responses fast. For example, a webhook or HTTP trigger function might require an acknowledgement response within a certain time limit. It is common for webhooks to require an immediate response. You can pass the HTTP trigger payload into a queue to be processed by a queue trigger function. This approach lets you defer the actual work and return an immediate response. To the next topic, Azure Blob Storage. What is Azure Blob Storage? It is Microsoft's object storage solution for the cloud. Blob storage is optimized for storing massive amounts of unstructured data. Unstructured data is data that doesn't adhere to a particular data model or definition, such as text or binary data. In this diagram, you can see Azure storage architecture. For now, we will focus on a blob storage. Blob storage is further divided into three different parts. We have block blobs that are used for storing text or binary files like large images and videos. Then we have append blobs that are used for storing logging and monitoring data. And then we have page blobs. These are mainly used for disks like virtual machine disks and Azure SQL. About the access tier for blob data, data stored in the cloud grows at an exponential pace. To manage costs for your expanding storage needs, it can be helpful to organize your data based on how frequently it will be accessed and how long it will be retained. Azure Storage offers different access tiers so that you can store your blob data in the most cost effective manner based on how it is being used. Azure Storage access tiers include Hot tier, An online tier optimized for storing data that is accessed or modified frequently. The hot tier has the highest storage costs but the lowest access costs. Then we have cool tier, an online tier optimized for storing data that is infrequently accessed or modified. Data in the cool tier should be stored for a minimum of 30 days. The cool tier has lower storage costs and higher access costs compared to the hot tier. Then we have cold tier, an online tier optimized for storing data that is rarely accessed or modified, but still requires fast retrieval. Data in the cold tier should be stored for a minimum of 90 days. The cold tier has lower storage costs and higher access costs compared to the cool tier. Then we have archive tier, an offline tier optimized for storing data that is rarely accessed and that has flexible latency requirements. On the order of hours, data in the archive tier should be stored for a minimum of 180 days. Azure storage capacity limits are set at the account level rather than according to access tiers. You can choose to maximize your capacity usage in one tier or to distribute capacity across two or more tiers. Manage and find Azure blob data with blob index tags. As datasets get larger, finding a specific object in a sea of data can be difficult. Blob index tags provide data management and discovery capabilities by using key value index tags attribute. You can categorize and find objects within a single container or across all containers in your storage account. As data requirements change, objects can be dynamically categorized by updating their index tags. Objects can remain in place with their current container organization. Blob index tags let you dynamically categorize your blobs using key value index tags, quickly find specified tagged blobs across an entire storage account, specify conditional behaviors for blob APIs based on the evaluation of index tags, and use index tags for advanced controls on features like blob lifecycle management. Change feed support in Azure Blob Storage. The purpose of the change feed is to provide transaction logs of all the changes that occur to the blobs and the blob metadata in your storage account. The change feed provides ordered, guaranteed, durable, immutable, read-only log of these changes. Client applications can read these logs at any time, either in streaming or in batch mode. Each change generates exactly one transaction log entry, so you won't have to manage multiple log entries for the same change. The change feed enables you to build efficient and scalable solutions that process change events that occur in your blob storage account at a low cost. To the questions related to the same topic, question 6. You are developing an application to store business critical data in Azure Blob Storage. The application must meet the following requirements. Data must not be modified or deleted for a user specified interval. Data must be protected from overwrites and deletes. Data must be written once and allowed to be read many times. You need to protect the data in the Azure Blob Storage account. Which two actions should you perform? Here, we are trying to develop an application that must not be modified or deleted for a user specified interval, must be protected from overwrites and deletes, and must be written once and allowed to be read many times according to the given requirements. We want to protect the data in the Azure Blob Storage account. According to all these, the two actions that we can perform are configuring a time-based retention policy for the storage account and enabling version level immutability support for the storage account. Thus, the correct options are A and D. A. Time-based retention policy stores blob data in a write once, read many format for a specified interval. When a time-based retention policy is set, clients can create and read blobs but cannot modify or delete them. After the retention interval has expired, blobs can be deleted but not overwritten. D. Before you can apply a time-based retention policy to a blob version, you must enable support for version level immutability. Question 7. You are developing an application that uses Azure Blob Storage. The application must read the transaction logs of all the changes that occur to the blobs and the blob metadata in the storage account for auditing purposes. The changes must be in the order in which they occurred, include only create, update, delete, and copy operations, and be retained for compliance reasons. You need to process the transaction logs asynchronously. What should you do? Here, we are developing an application that reads the transaction logs of all the changes that occur to the blobs and the blob metadata in the storage account for auditing purposes. The changes must be in the order in which they occurred and include only create, update, delete, and copy operations, and should be retained for compliance reasons. Considering all these, the most appropriate option here is to enable the change feed on the storage account and process all changes for available events. Thus, the correct option is B. The purpose of the change feed is to provide transaction logs of all the changes that occur to the blobs and the blob metadata in your storage account. The change feed provides ordered, guaranteed, durable, immutable, read-only log of these changes. Client applications can read these logs at any time, either in streaming or in batch mode. The change feed enables you to build efficient and scalable solutions that process change events that occur in your blob storage account at a low cost. Question 8. You are building a website that uses Azure Blob Storage for data storage. You configure Azure Blob Storage Lifecycle to move all blobs to archive tier after 30 days. Customers have requested a service level agreement for viewing data older than 90 days. You need to document the minimum SLA for data recovery. Which SLA should you use? Here in this question, we are using Azure Blob Storage for data storage and have configured it to move all blobs to the archive tier after 30 days. Customers have requested a SLA for viewing data older than 30 days. As such, the most appropriate option here is between 1 and 15 hours. Thus, the correct option is B. The archive access tier has the lowest storage cost, but it has higher data retrieval costs compared to the hot and cool tiers. Data in the archive tier can take several hours to retrieve depending on the priority of the rehydration. For small objects, a high priority rehydrate may retrieve the object from archive in under 1 hour. Question 9. You develop a web application that provides access to legal documents that are stored on Azure Blob Storage with version level immutability policies. Documents are protected with both time based policies and legal hold policies. All time based retention policies have the allow protected append rights property enabled. You have a requirement to prevent the user from attempting to perform operations that would fail when a legal hold is in effect and when all other policies are expired. You need to meet the requirement. Which two operations should you prevent? Here, our requirement is to prevent the user from attempting to perform any operation that would fail only when a legal hold is in effect and when all other policies are expired. As such, the two operations that meet this requirement are deleting documents and overwriting existing documents. Thus, the correct options are B and D. Question 10. Hotspot. You are developing a solution to store documents in Azure Blob Storage. Customers upload documents to multiple containers. Documents consist of PDF, CSV, Microsoft Office format, and plain text files. The solution must process millions of documents across hundreds of containers. The solution must meet the following requirements. Documents must be categorized by a customer identifier as they are uploaded to the storage account. Allow filtering by the customer identifier. Allow searching of information contained within a document, and minimize costs. You create and configure a standard general purpose V2 storage account to support the solution. You need to implement the solution. What should you implement? To answer, select the appropriate options in the answer area. To the answer area, requirement. Search and filter by customer identifier. Here, as we want to search and filter data by customer identifier, we would use the Azure Blob Index tags. To the next requirement, search information inside documents. For this requirement, we will use Azure Cognitive Search. About the options, box 1. As datasets get larger, finding a specific object in a sea of data can be difficult. Blob index tags provide data management and discovery capabilities by using key value index tags attributes. You can categorize and find objects within a single container or across all containers in your storage account. As data requirements change, objects can be dynamically categorized by updating their index tags. Objects can remain in place with their current container organization. Box 2. Only index tags are automatically indexed and made searchable by the native blob storage service. Metadata cannot be natively indexed or searched. You must use a separate service such as Azure Search. Azure Cognitive Search is the only cloud search service with built in AI capabilities that enrich all types of information to help you identify and explore relevant content at scale. Use cognitive skills for vision, language, and speech, or use custom machine learning models to uncover insights from all types of content. To the next topic, Azure Logic Apps. What is Azure Logic Apps? Azure Logic Apps is a cloud platform where you can create and run automated workflows with little to no code. By using the Visual Designer and selecting from pre-built operations, you can quickly build a workflow that integrates and manages your apps, data, services, and systems. Azure Logic Apps simplifies the way that you connect legacy, modern, and cutting edge systems across cloud, on premises, and hybrid environments. You can use low code, no code tools to develop highly scalable integration solutions that support your enterprise and business to business scenarios. B2B enterprise integration workflows with Azure Logic Apps and Enterprise Integration Pack. For B2B solutions and seamless communication between organizations, you can build automated, scalable enterprise integration workflows by using Azure Logic Apps with the Enterprise Integration Pack. The following diagram shows the high level steps to start building B2B Logic App workflows. First, create integration account. Then, add partners, agreements, and other artifacts. Create a Logic App resource. Then, link integration account to Logic App. And then, build workflow using artifacts. To the questions related to this topic, question 11. You are a developer at your company. You need to update the definitions for an existing Logic app. What should you do? What should you use? In this question, we want to update the definition for an existing logic app. As such, the most appropriate option here is to use the logic app code view. Thus, the correct option is B. Edit JSON to Azure portal. First, sign into Azure portal. Then, from the left menu, choose all services. In the search box, find logic apps, and then from the results, select your logic app. Then, on your logic apps menu, under development tools, select logic app code view. The code view editor opens and shows your logic app definition in JSON format. Question 12. You are a developer at your company. You need to edit the workflows for an existing logic app. What should you use? Here, as we want to edit workflows for an existing logic apps, we will use the logic apps designer. Thus, the correct option is D. The logic apps designer. To edit the workflows for an existing logic app, you should use the logic app designer. The logic app designer is a visual interface that you can use to create, update, and manage logic apps. The designer allows you to define the triggers, actions, and conditions that make up the logic app's workflow. You can use the designer to add, remove, or modify the connectors, expressions, and actions that make up the logic app. These were all the questions for this video. You can download the complete PDF of this video and our practice questions through the link down in the description. We will be publishing more videos in the future, so please make sure to subscribe our channel and press the bell icon. Thank you for watching and stay tuned.